In graph 10.7, we showed how a tax on housing is inefficient because it distorts the price of housing and would allow us to construct, in principle, a lump sum tax that can raise more revenue without making the consumer any worse off. You might have noticed in that graph that the reason we can raise more money under the lump sum tax is because of a substitution effect, because bundle B was different than bundle A. We will now show that the substitution effect is in fact the only reason why the housing tax is inefficient. As we reduce the substitution effect, the inefficiency is reduced, and as we expand the substitution effect, the inefficiency increases. As in graph 10.6, we begin with the blue before tax budget constraint. The imposition of the housing tax then again raises the price of housing and thus causes a steeper after-tax budget constraint. The only way in which we'll deviate from what we did in graph 10.6 is that we'll now assume that the indifference curve that generates the optimal decision on the after-tax budget constraint has a shape for perfect complements. At the optimal bundle A, we again have housing consumption of HA and other goods consumption of CA. Had we consumed the same level of housing HA prior to the imposition of the tax, we would have consumed bundle alpha and thus enjoyed a other goods consumption level of C alpha. The difference between C alpha and CA is then again the tax payment T that we made as a result of the imposition of the housing tax. In this case, it's very clear that alpha is not the optimal bundle on the blue budget constraint. We're again simply using alpha to pin down what the tax payment T is after the tax is imposed when we optimize at bundle A. And we can measure that tax payment T in dollar terms on the vertical axis because, once again, we've put dollars worth of other goods on the vertical axis and thus are measuring the units on the vertical axis in dollars. In order to determine how much we could have taken away from this consumer in a lump sum fashion instead, without making her any worse off, we started the blue budget and shifted inwards in a parallel fashion until it is just tangent to the original indifference curve. That tangency, or quasi-tangency, now happens at point A. Because we've assumed the perfect complement shape for the indifference curve, we therefore have no substitution effect, and the point we previously labeled B in graph 10.6 coincides with point A. The shift from the blue to the green budget represents the most that we can take from this consumer in a lump sum fashion without making her any worse off than she is under the housing tax. And since the blue and the green lines are parallel, we can measure the difference between those as a vertical distance in dollar terms anywhere. In particular, we can measure it as the vertical distance below alpha, and that distance is now exactly equal to T because point A is exactly equal to B. Thus, the highest possible amount we can raise under the lump sum tax, L, is equal to the tax payment this consumer makes under the housing tax, T. Put differently, we've now encountered a case where we cannot in fact think of a way of raising more revenue from this consumer without making her any worse off. Thus, the housing tax in this case is efficient. We'll go through this sequence one more time in panel B, only this time we'll assume an indifference curve that has a great deal more substitutability built into it. We'll again start with the before tax budget constraint, and we're making it a bit shallower here just to make it easier to illustrate a large substitution effect a bit later on. The imposition of a housing tax again causes an increase in the price of housing and a steeper after-tax budget. To determine how much of a tax payment this consumer actually makes, we again have to start by determining what the optimal consumption bundle for the consumer is after the imposition of the tax. We'll do so here, but now assume an indifference curve that is relatively flat, and thus has a great deal of substitutability built into it. At the optimal bundle A, the consumer again consumes HA square feet of housing and CA dollars worth of other goods consumption. Had the consumer consumed the same level of housing prior to the imposition of the tax, she would have consumed bundle alpha and therefore had C alpha left over for other goods consumption. The difference between C alpha and CA on the vertical axis is then again equal to the actual tax payment that the consumer makes under the housing tax. To determine the most we could have taken away from this consumer in a lump sum way without making her any worse off than she is under the housing tax, we again shift the blue budget constraint in a parallel way until it is tangent to the after-tax indifference curve at bundle B. The vertical difference between the blue and the green lines can again be measured starting at the point alpha and is indicated on the vertical axis as L, the highest lump sum tax payment that we could have elicited from this consumer without making her worse off than she is by paying the tax payment T under the housing tax. Since we could have raised a lot more in a lump sum way than we did in the distortionary way, we would say that the housing tax in this case is very inefficient. The reason why the lump sum tax payment L is so much larger than the distortionary tax payment T in panel B of our graph is because bundle B lies so far to the right of bundle A, and as a result the green budget line lies so far below bundle A. Put differently, the reason we have a difference between a lump sum tax payment and a distortionary tax payment is because of the substitution effect that is present in panel B but not in panel A. The difference between L and T disappears as the difference between B and A disappears. As the substitution effect goes away, so does the inefficiency. As the substitution effect increases, so does the inefficiency. The reason why it is inefficient to raise tax revenues through price-distorting taxes is therefore not because we have to write checks to the government, but rather because in the process of writing checks to the government, we're distorting our behavior in part to avoid the tax. And the more substitutable the tax good is with other goods, the more we will substitute into non-taxed activities in order to avoid that tax. It's that substitution effect of a tax that creates the inefficiency.